Let's take a look at what happens in what's called a divergent plate boundary. The divergent plate boundary is what happens when two plates within plate tectonics, the outer earth of the crust, actually move apart. So what causes that to happen, and what are some of the landforms that we see? It turns out we can do an experiment to demonstrate some of these things right here in your own kitchen, as always on Geology Kitchen. Allie and I are going to build a giant version of one of these. We call these toaster pastries. They have a hard outer layer that has a soft, gooey filling inside. And with that, we can kind of remodel some of the things that happen in a planetary scale. But we really wanted to do something that was a little bigger and easier to see. So we're going to make a giant toaster pastry. And here's how we're going to do it. First of all, you're going to need a pan. You're going to need some parchment paper. And then we're going to need to go and get some pie crusts, usually from the freezer section of your grocery store. And they come in rolled up pieces like this. You'll cut those out, and Allie's going to help me by actually creating this over here on our pan to the left, right? Mm-hmm. And so we're going to cut these packages, and we're going to get these out and take a few minutes to unroll this onto the parchment paper. Now, one thing we want to do is be sure and spray some non-stick material like this canola oil onto the paper, so that way our pie crust doesn't stick to the paper when we try to remove it later. So let's go ahead and do that. Perfect. Okay, and then we'll cut a few of these out. I'll work on this one. And then we're going to take and actually unroll these and lay out a layer of pie crust. I didn't cut that quite enough. Let's get it a little bit here. We're going to cut this out and unroll it and essentially fill up our pan with pie crust. So we're going to create the bottom layer of our pastry first. We're going to take two of these pie crusts that you would normally put in a pie pan and lay them out flat with a little bit of overlap. We can use a little bit of water to seal the two together. And what we'll end up with is an elongated piece of pie, and we'll have to cut off a third piece in order to fill the gaps along the side, because we want to get something that fits the square pan as best that we can. So what in the real earth does this represent? Since this is the bottom of our crust filling crust sandwich, if you will, this really represents the top of the mantle in the earth. As we go far enough down into the earth, pressure and temperature increase. And before it gets too high pressure, some of those rocks melt, and that would be the gooey filling inside this pastry. If you go down further into the earth, into the mantle, the pressure gets high enough where the rocks can no longer melt, because there's just too much pressure to allow them to, even though it's very hot. And so that then mechanically is very hard, and that is essentially what we're representing by this lower piece of pastry. And so we've already built the top part of one of the layers of our earth here, in the mantle. And now what we want to do is we want some filling. Now what we've got here is some strawberry jam. So what we're going to do is we're going to pile this in the middle. Okay, and we're going to make a thin layer across the inner 2/3 or so of this pie crust, being careful to leave the outside 1.5 inches or so, or 2 inches even, without having jam on it. I'm going to let Allie spread this out, and we want a layer that's about 1/4 to 1/3 of an inch thick. Okay, I'll go ahead and scoop and you spread. Now, the filling is the molten rock or the magma that's forming at the boundary between the cold crust, which is forming at the Earth's surface, and the top of the mantle. And in that zone, the pressure is a little bit lower, but the temperature is still very hot, and that allows a little bit, a portion, of the rocks to melt. And mechanically, what we think that interface is something like a jam, or maybe even toothpaste in consistency. And so even though it's very strong and has solid-like behavior, it flows over time like fluid would. And so that's going to affect what the crust looks like on top, because it's a bit like walking across ice or having something, taking roller skates across a parking lot where you have very little friction below because you've got this layer of moving rock below a layer of solid rock. So when we think about divergent plate tectonics, what are we really talking about? These are places where magma comes close to the surface and actually through cracks in the ocean floor moves up and forces the plates apart. We call that ridge push because the point where the magma comes up is called a spreading center and creates a mountain range formed from the cooling magma, and that's called a mid-ocean ridge. We're going to actually demonstrate how a mid-ocean ridge forms with our toaster today. I think that's enough. What do you think? I think that's good.
Yeah, that's really good.
Okay. So we've completed our model of our magma sitting on top of our upper mantle. Now what we need to do is we need to lay our top piece. Okay? So where this magma touches the air and touches the hard ocean, it's very cold and it freezes back into a solid again. And that is what our top piece represents. All right, so we're going to unroll it this way. Got it? Just going to lay it over and we can fix it. There we go. So once you get your top piece laid on top, we're going to basically push down the two pieces of crust around the edge of the filling, and that will form the tight bond of our pastry. Okay, we've pulled our pastry out of the oven and now it's cooled down, and we can already see that as the filling, our magma heated up, it started to rise and it found cracks in the edges and in the middle and actually came through. And this is exactly what happens with ocean crust. That magma looks for weaknesses and comes up, and here we have the beginnings of a feature called a mid-ocean ridge or a seafloor spreading center. Okay, and so this is a long fault or set of fractures or faults that form, and they actually bring magma up to the surface. Okay, before we do anything more to this though, we're going to go ahead and put our icing on. Get that brittle, cold crust in place, and then we'll come back and break it. So we're finally ready to demonstrate a divergent plate boundary with our giant toaster pastry. And here's what we're going to do. So we've lifted this out of the pan on the parchment paper. And in reality, what's happening under the ocean crust is the mantle is convecting. And what that means is hot magma is coming up along this portion of the ocean's crust. And as it heats up, it pushes upward on the back of the ocean crust, allowing it to pull or be pushed apart. So what we're going to do to simulate that is we're going to stress the middle of this with this piece of pie crust. This is going to be like sleeping on a mattress that has like something under your back. It doesn't feel very comfortable. It's the same thing for a plate that's undergoing stress from magma rising up underneath it. So let's pick up both edges of this, pick it up. We're going to set it gently right on top of this, and then watch what happens. Okay, now we can actually see what's happened here. Okay, you see that the whole crust is now broken. It's broken apart because of this underneath is creating stress. And the weight of both of these halves now wants to pull them apart. So Allie, why don't you grab these two sides and we'll see if we can coax these two sides apart. Okay, we pull it just apart. Okay, now we've gotten it pulled apart. Now you can see the magma, right? You can actually see the area where magma is now coming out from underneath this slab of ocean rock, and it's filling this long gap in between. That's what we call a spreading center. This forms a mountain ridge. You see how this pops up? There's literally underwater mountain ranges that are thousands of miles long called mid-ocean ridges. And they mark these places where the magma comes up to the surface because the ocean crust is broken and is moving apart. So that is a great, great model for a spreading center. And as the edges, it's getting cold. And as it gets cold, it puts pressure and sinks. And it'll actually push down and squeeze some additional magma up. And now I've got my hands all over our nice toaster pastry. But long story short, it's a great way to have fun making this giant piece of food to demonstrate how plate tectonics works in a divergent plate boundary setting.